Hello everyone. Today we are excited to present our project on Microsoft stock price prediction. My name is Manasa and my team members are Bhavana, Bindu, Divya and Sinchana. Together we have collaborated to build and evaluate a predictive model using machine learning techniques. Uh, these are the contents. Next, we have introduction. This study focuses on predicting Microsoft stock prices using machine learning techniques. We leverage historical data, market sentiment, and economic indicators to improve prediction accuracy. Here we used various machine learning models, including linear regression, random forest, neural networks, to analyze patterns and forecast future stock prices. Different models have different strengths. For instance, linear regression is useful for trend analysis, while neural networks can capture complex patterns in stock movements. Our model is trained on historical stock prices, trading volume, and technical indicators to identify predictive trends. Stock prices are influenced by various factors like past performance, market sentiment, and economic conditions. Uh, and news articles and social media affect stock prices significantly. We integrate sentiment analysis to capture market sentiment fluctuations. We we assess the effectiveness of each model based on prediction and accuracy and precision. This study demonstrates that machine learning can improve stock price forecasting and help investors make better decisions. By combining historical data, machine learning models, and sentiment analysis, we enhance stock price prediction accuracy. This approach can support investors in making more informed decisions.
Problem statement. In this project aims to develop a machine learning model that can predict a Microsoft stock price prediction and analyzing a combinations of factors, historical stock price and technical indicators like moving average and microeconomic factors such as interest rate and next is market sentiment and to analyze this well used several machine learning algorithm including linear regression and random forest and long short term memory and also using natural language processing analyzing sentiment from financial news and social media. This helps to understand how public mood might uh, affect the stock price. And the next is our next mean absolute errors and root mean square errors and r square errors. Next objectives in this objectives of the project developed a predictive model, build an accurate machine learning to forecast Microsoft stock price using historical data, technical indicators, and microscopic factors. Uh, Utilized advanced machine learning techniques. And next one is incorporate market sentiment analysis and optimize model performance and developed a real-time prediction system. Next we'll explain the way.
Now coming to the literature review. In the literature review, we have a title, authors, and the publication year and the summary. So the machine learning techniques for data stock marketing for a review. Authors are the WL law and the publication year is 2022. Summary is the providing extensive examination of the data and machine learning. A systematic review of and stock market using a machine learning statistical techniques. Authors are M.R. Hassan and the publication year is 2020. The reviews for the various machine learning statistical methods. So the role of the machine learning in predicting a stock prices, a literature survey. Authors are the A.L. Howard. The publication year is 2021. Explores the recent machine learning and the deep learning techniques. Stock prices based on a machine learning algorithms. The authors are H. Wang and publication year is the 2021. Investigates the use of the machine learning. Now coming to the methodology, we have implemented a 4 algorithm, that is a support vector machine, random forest algorithm, the long-term and the short-term memory, and the linear regression. Vector machine useful for the time series forecasting, which is with the high dimensional data. A machine learning model which is effective for the high dimensional data. The random forest algorithm, an assemble method which handles a non-linear relationships, which means that combining a multiple decision tree to predict the accuracy. Long-term and the short-term memories. Recurrent neural network captures the long-term memories, a special type of the neural networks which is captures the long-term dependencies. Linear regressions, the model stock price is based on a past data. It is a supervised machine learning model which learns from the labeled data sets. Now coming to the data acquitization and the data pre-processing. Data acquitization means cleaning the data, and pre-processing means cleaning and organizing the data. The historical data means refers to the collecting a data from the relevant data from the histories of past data which is relevant to our topic. The key features selecting the most relevant domains that is related to our project, and the technical indicators refers to the indicators which are the r square detect the patterns or the trends. Data cleaning means removing the duplicates and handling missing values. Next further will be continued by Bindu.
To the model training and evaluation. Training. We train the model using the random forest regression on historical Microsoft stock price data. For example, we use a previous day closing prices, high, low, volume, and etc. The target of the next day closing prices. Evaluation. After training, we do the evaluations. In this evaluation, we compare prediction versus actual prices. Data splitting. To prevent a overfitting and testing models, generalizations, we split the data set into training set, testing set, and optimal. Training set we have for model learning, 80% of data we use. For testing, we use for evaluating prediction. For example, last 20% of data. Optional, we use a validation set to tune a hyperparameters separation from testing. Coming to hyperparameter tuning, which improve the performances. In this, n estimators, number of trees, for example, 100, 200, maximum depth and minimum sample split, maximum features. Coming to evaluation matrix, we have the ME, mean absolute error, average absolute between the prediction and real prices, MSE, mean squared error, square of the square, and sensitive to the largest mistake. RMSE, root mean squared error, the same unit as the stock price. R square score, how well the model explain the stock prices. Performance comparison. Once we train our RF models, compare it with other models or different RF settings, stock prices, low error and is equal to better performances. Next, coming to the graph, we have the x-axis and y-axis. Y-axis represented the stock prices and x-axis represent the year and the month. Yellow line represented the actual prices and blue line represented the training prediction, and magenta color represented the testing prediction. The close alignment of test prediction with the actual suggestion, strong forecasting performances. Next, we'll continue by Sinchana.
Coming to the hardware and software specification, we have software requirements. First one, we have programming languages, which is Python and R. Python, which is used as the best choice for machine learning, and R is used as a statistical analysis. Second one is libraries and tools. In libraries and tools, we have data handling, NumPy visualization, and Seaborn machine learning. Data handling includes pandas, and NumPy visualization includes matplotlib, and Seaborn machine learning includes scikit-learn and TensorFlow. Have hardware requirements. First one, we have basic and advanced. Basic is nothing but it is for small dataset and simple modules, and advanced is for deep learning and large datasets. In basic, we have CPU, which is control processing unit, is of Intel i5 core, and RAM is nothing but random access memory, which is 8 gigabytes, and storage is about 256 gigabytes SSD. Advanced CPU is about Intel i7 or i9 core, and random access memory is about 16 GB, or it can be more, and storage is about 512 GB and SSD. Limitation and future work. We have historical data, external factors, and sentimental analysis. Historical data includes model relies on historical data patterns, which usually collects the algorithms from the historical data and it trains the machines. And external factors, it is not fully accounted for. For training the machine learning, which doesn't include the external factors. And sentimental analysis includes the incorporate news and social media. Sentimental analysis is nothing but the emotional views of the persons that are giving the in the social media. Thank you.